Have you ever stared up at the night sky and dreamed of actually going to those stars? Not in some distant future, generations from now, but like next week? Well, today we're going to explore a truly mind-bending idea that connects wild science fiction with some pretty serious theoretical physics. We're talking about how an artificial superintelligence might be the one thing that finally unlocks faster-than-light travel. So how would that even work? Let's dive in.
Now this sentence, this is the key to the whole thing. Just let it sink in for a second. It basically says that to a powerful enough intelligence, the universe's rules aren't really rules. The fabric of space-time itself becomes programmable, like a piece of clay. That's the mindset you have to be in to really get what we're about to talk about. All right, so where do we even begin? Well, this isn't just stuff made up for movies. We're going to ground this whole conversation in a real physics, even if it is highly theoretical. And it all starts with an idea called the Alcubierre drive.
Okay, so the central idea here is a total game changer. The ship, right? It doesn't actually break the speed of light by flying super fast through space. No. Instead, it creates a little bubble around itself that literally squishes space-time in the front and stretches it out in the back. The ship just sits there completely still inside the bubble while the universe itself does all the moving.
The best way to think about it is like a surfer riding a huge wave. The surfer isn't moving through the ocean. They're being carried by the wave. The Alcubierre drive is the exact same idea, but the wave is made of space-time itself. So if the math checks out, why aren't we already hopping between star systems?
Well, there is a big difference between a cool idea on a blackboard and actually building the thing. It turns out there are a couple barriers that are so massive, so completely overwhelming, that they've kept this amazing technology stuck in the world of dreams.
We're going to zero in on the two biggest deal breakers. First up, the energy. It requires an amount of energy that is just insane. And not just any energy, a weird kind that we're not even sure exists. And second, there's the navigation. I mean, how do you steer something that's moving faster than you can see what's in front of you? So let's start with that energy problem. To bend space-time like this, the original math said you need something called negative energy, and the amount you need was staggering. We're talking about the energy equivalent of the entire mass of the planet Jupiter. Yeah, not a car battery, not a power plant, a whole planet. It's just fundamentally beyond us.
And even if you could solve the energy problem, you've got the navigation. See, when you're moving faster than light, you'd slam into a tiny speck of dust before its light could even reach you to let you know it was there. To dodge it, you'd need to react in what's called Planck time, the smallest possible unit of time. It's so fast, it's not just faster than a human, it's faster than physics allows biology to be.
So, we've got an impossible energy requirement and an impossible control problem. Looks like it did end, right? Well, this is where the plot twists. This is where we introduce the one thing that could change the equation completely: artificial superintelligence, or ASI for short.
Now let's be really clear. We are not talking about the AI that suggests what you should watch next. An ASI is a future AI that isn't just a little smarter than a person, it would be more intelligent than the entire human species combined. It would operate on a level of thinking that we literally can't even begin to imagine.
To really see the difference, let's look at this timeline. Right now, up to around 2030, we're in the era of ANI, or narrow AI. It's great at specific tasks. Sometime after that, we get to AGI, or general AI, which could think and reason like a human. But the giant leap, maybe around 2040 and beyond, is to ASI. That's when an AI doesn't just think about the universe, it starts to rewrite it.
Okay, so we have this almost godlike intelligence on our side. How does it actually go about solving those impossible problems we talked about? Well, this is where it gets really interesting, because an ASI wouldn't just use our physics, it would finish it.
An AI would basically launch a three-pronged attack on the problem. First, it would completely rethink the energy issue. Second, it would invent brand new technologies to handle the navigation. And third, it might just find a shortcut that makes the first 2 points almost irrelevant.
So first up, energy. Remember that Jupiter-sized problem? An ASI will probably look at our math, find a much more elegant and efficient shape for the warp bubble, and with a few tiny tweaks at the nano level, it would slash that energy requirement. We go from needing a whole planet's worth of energy down to just a few kilograms. It might even figure out how to pull that energy directly from the vacuum of empty space.
And for the navigation, an ASI would invent things straight out of science fiction. It could build sensors using quantum entanglement that would allow it to see what's ahead instantly, no light speed limit. It would also solve another huge problem, the deadly radiation the bubble would create by just, inventing and building a gravitational shield to protect everyone inside. Easy enough for an ASI.
This chart really shows you why it has to be an ASI. The AI we have now, ANI, is like a really good calculator. It can help us with the math. A future AGI would be like a brilliant scientist. It could run simulations and propose new theories. But only an ASI could be the master engineer. It's the one that can actually control vacuum energy, build the shields, and pilot the ship. That leap in capability is what makes this all possible.
But here's the absolute mind melter. An AI might not even bother with a warp bubble at all. If theories like string theory are right and there are extra dimensions we can't see, an AI could figure out how to access them. Instead of traveling across our universe, it could just take a shortcut through a higher dimension, cutting the travel time down to practically zero.
So, what happens if this actually works? What are the real consequences? Because if an AI manages to pull this off, it's not just a new engine. It fundamentally changes what humanity is and where we fit in the universe.
Let's just try to get a sense of the scale here. The trip to our nearest star, Proxima Centauri, with today's tech, it would take us about 75,000 years. With an ASI warp drive, it's a few hours. Just think about that. You could visit another star system for the day. And if you think that's crazy, what about crossing our entire Milky Way galaxy? A journey that is so long it's functionally infinite for us today. With this technology, maybe a few weeks. The entire galaxy would shrink down to the size of a continent you could explore.
Look, in the end, this isn't about speed. It's about evolution. This is the kind of breakthrough that would instantly transform humanity from a civilization stuck on one planet, a so-called Type 1, into a Type 2 or even Type 3 civilization. A species that is spread across the galaxy and can command the energy of stars.
And that really brings us to the final, biggest question. The physics and the engineering are fascinating, but the real question is philosophical. When the stars are no longer out of reach, when our neighborhood becomes the entire galaxy, what happens to us? Who do we become? That's really something to think about.